So thank you for the introduction. I'm Chiara Bardelli. I'm a PhD student at the University of Pavia. And I will start saying that this presentation is very, very applied. And the reason is that my PhD is funded by a company, which is Datev. And we are trying to integrate a machine learning model into a business process that we briefly see in this presentation. So this is the outline. We will see an introduction and on the domain of the data and on the problem. Then we will talk a little bit about the REFIT problem that we face to. And then I will show you the approach that we decided to use to improve the prediction performance of our model. And then we will see some conclusions. So why, Datev is a software company, and it's a company that develops software for the accounting process. And why this company is interested in a development of a classification model, the reason is that part of the accounting process is a very repetitive and monotonous task, which takes a long time. So this is a very, very simple scheme. Basically, we have an invoice, which is a document in an XML format, and we have some description and text inside this invoice. Now there is an officer that analyzes the invoice and decides the best code that describes the economic nature of these transactions contained in the invoice. And these codes are part of the bookkeeping journal, which is the registration of all the transactions of the company. So if we translate this problem into a machine learning model, we have the input variables that are the invoices and the characteristics of them. And then we have the target variable that are the codes that describes the economic nature of the invoice. And then we want to find a classifier that here is F in order to minimize a prediction error that very often is simply the accuracy, so the number of the codes that we classify correctly. So here we have another schema to clarify the unit of the classification is the line of the invoice. So for each line of the invoice, we have some information and some other information related to the context, which is usually the sender or the receiver of the invoices and their main occupations, like, for example, restaurant or schools or university, because every company or other institutions has to create this bookkeeping journal. And then we have the target variables that in our case are 3, and we have to develop 3 different machine learning models for each of these codes that we can see on the right side of this slide. So we have a first phase that we already concluded, that is the training phase of our model. At the beginning, we integrated different data sources from different companies, so we had a problem of match these data sources. Then we created our training set and test set, and since inside our training and test set we have a lot of textual descriptions, we used a word-to-vec model to translate these textual description into a numerical data matrix, in order to use all this information to train our final classification model. And this phase is almost concluded, and we found the best classification model that now is the XGBoost model. But then it's the most difficult phase, because we have the phase 2, that is the prediction, because here we have to include the classifier in the business process and in the software of Datev company. So we have a new invoice that arrives, and instead of the officer, we have the machine learning classifier. The machine learning classifier proposes some codes, and these codes are validated by the officer. The officer sees the codes and decides if these codes are correct or not correct. But this process obviously is very restricted to a small subset of these invoices, because we cannot ask to the officers to check all these invoices. And then at the end we have some feedback data provided by the officers that are very useful, because they are another way to evaluate our models instead of the prediction performance computed on the test set. So we want to include these feedback data inside our process to improve the prediction performance. And this is our REFIT problem. So one possible approach that we tried is very simple. We take the feedback data, and then we give to this feedback data higher weight with respect to the historical data than we had before. But we tried this approach, and unfortunately it was not so good, and this is an example. Here we have an invoice that is a new invoice related to a list of products that are drinks, because the invoice is related to a restaurant. And we have 3 different codes that are the accounting codes. And if this invoice was correctly classified, we expect that all the lines related to wines were classified with this code, all the lines related to beers with this code, and all the lines related to generic and alcoholic drinks with the last one. Unfortunately, since these codes were not so frequent inside our training set, the original one, the machine learning classifier wasn't able to discriminate between these 2 last codes. So the officer sent us back his feedback with the correct data, and we include this data with a higher weight inside our model. And here we have a table with with the sum of the values that we used to see if the model was able to learn this new data. Here we have the recall index, that is an index that measures the performance of the model related to the test set. And if we do not introduce any feedback in that it's the invoice that we previously seen, we can see that the recall is very high. But the recall on the invoice that we have just seen is not so good. So then if we increase the weight of the feedback, so here we are included also the invoice, the previous invoice in the training set, we can see that the recall on the test set decrease, and the recall on the new invoice obviously increases a lot. But we do not want to, we don't want a classifier that learns very well only the invoice of the feedback data and lose accuracy on the old test set and training set. So we decided to try another approach, and this is the approach that now we are testing. We have 2 streams of models. The first stream is the stream that we already seen. We have a single classifier with a single word-to-vec model trained on the entire data set, training and test set that includes all the invoices of all the companies. And then we have a second stream. This second stream uses only feedback data. So we have n different word-to-vec models that learn from n different feedback data that are related, each one to a specific company. And then we have n different machine learning classifier that learn from only this data about this company. So this is, obviously, in this case, we have a very high accuracy on the feedback data, and we can use this approach to learn more about feedback data without losing accuracy on the test set. But the problem is when we have to decide to choose the model in the prediction phase, which is the model that which is the stream that we decided to use. And we use the output of the word-to-vec model to discriminate between the two streams. So in this case, when a new invoice has to be processed, first of all, we check if there are feedback data about that company. And then we apply, if this feedback data exists, we apply the word-to-vec model trained only on the feedback data of the company. If the result is a vector equal to 0, this means that the text inside of the invoice has never been seen by the word-to-vec model and the machine learning classifier, and so the global stream is applied, that is the first one. Otherwise, we can use the single stream that includes more accurate data on, related to the feedback data. So in this case, obviously, we have good results, very, very precise results for invoices that are very similar to feedback data already provided to us. And we can use the global information that we learned with the first stream. So we are testing this procedure with the customers, with the users of the software. And what I can say is that seems very promising with respect to the previous one that we have seen related to the weights. And so in conclusions, I gave you some ideas of what is the integration of a machine learning classifier inside a business process. Then we have seen very briefly the REFIT problem that we had, and the fact that we can use this word-to-vec model to discriminate between the use of the stream global or the stream related to the single companies. And then we have seen that we will see probably that this approach can provide very good results. So there are a lot of other things to do and many open problems to solve, because there is here we have a lot of steps from the preprocessing phase to the integration of the prediction into data software. And we also have an unbalanced classification because in case of accounting codes, we have a very high number of classes, and so it's not so easy for the classifier to learn, especially the relations in case of very of low frequent classes. Then also here we are considering lines of the invoices independent, but this is not so true, because lines that belongs to a single invoice obviously share some information that we can maybe exploit to improve the prediction performance. And then there is a very big problem with the optimal sample size of the training set, since we have potentially thousands and thousands of invoices, but we know that if we increase the number of training sets, usually performance cannot always improve. So here there are some references about word-to-vec model and XGBoost and another work about this, a preliminary work about this presentation, and thank you for the attention.
Are there any questions? Yes?
Yeah, I was thinking, do you have any hypothesis of the bad performances of the one with the weighted?
Okay, the one with the weights. Okay. So, okay, I think the problem is the sample size, because feedback data, the size of feedback data compared to the size of the training set is very, very low. We have like more than 200,000 of lines of invoices in the training set in this example, and here we have only 79 lines of invoice. So we have to increase a lot. We can see here the weight of this new invoice to see some results on the new invoice. So I think this is the problem.
Any other questions? And we thank again the speaker.